Hi, my name is Nick, and welcome to the pool. In this instructional video, I'm going to show you how to test the pool chemicals, and then we'll talk a little bit about the role that each chemical plays in the day-to-day operation of the swimming pool. Let's get started. Let's start with chlorine, also known as sodium hypochlorite. Chlorine, the main sanitizing agent in the pool, is responsible for keeping the pool free of any biological material that poses a health risk to swimmers. We use chlorine because it is a cheap and effective way to keep the pool clean. Chlorine comes in many containers, but at many of our pools it comes in a 5-gallon container called a carboy. In normal operation, chlorine is added to a large vat in the pump room, which is automatically fed into the pool by a roll-a-chem machine. The roll-a-chem machine is turned on and off by a controller which uses sensors to detect high or low chlorine levels in the pool. Because it uses a very delicate sensor, always consult one of the SwimJim pool operators before adjusting the dial. When you are doing any type of chemical test, it is important to get a sample of water below the surface, since the chemicals on top have reacted more to air and light and are not representative samples of the pool. To test the chlorine level in the pool, fill up a 10 milliliter test tube halfway to the 5 milliliter mark. Add a tablet from the green lettered foil package that reads DPD1. The water should turn from clear to pink. Insert the test tube into the slide comparator, then insert the slide. Match the color of the water sample to the color on the slide. This water, for example, reads 2.5. This is the amount of free available chlorine that is in the pool ready to clean. To test the total chlorine, take the same sample of water and add a tablet from the blue lettered foil package that reads DPD3. The water should remain the same color or turn a darker shade of pink. Compare the colors the same way you did for free chlorine. This water, for example, has a total chlorine of 3 parts per million. This is the amount of available chlorine as well as the amount of used and now inactive chlorine. To calculate the combined chlorine, take the total chlorine, which is 3, and subtract the free chlorine, which is 2.5. That leaves you with a combined of 0.5. Easy, right? To rid of combined chlorine, the pool must be superchlorinated, also known as a shock treatment. When we shock the pool, a pool operator adds enough chlorine in the pool to bring the total chlorine level to 10 times the amount of the current total chlorine. When this happens, the pool reaches what is called the break point, and all the inactive combined chlorine undergoes a process of oxidation which breaks up the chemical bonds of the chloramines and releases it into the air. The chlorine level in the pool should be kept between 1.5 and 3 parts per million. The combined chlorine should never be higher than 1 part per million. Now let's talk about pH. The letters pH come from the Latin potens hydrogen, or hydrogen ion potential of a given sample. A higher pH means the water has a greater capacity to carry hydrogen ions. We call this base. A lower pH means a lower hydrogen potential, which makes the water acidic. The pool is kept in an ideal pH of 7.5 because that is the pH of the fluid in the human eye. That is why a high pH or a low pH can irritate the eyes of swimmers. To lower pH levels, we can use sodium bisulfate or muriatic acid. To raise pH levels, we can use sodium carbonate. Also be aware that other chemicals, like chlorine, can affect the pH of a pool. To test the pH, fill up a 10 milliliter test tube. Add a tablet from the red lettered foil package that reads pH. Cap and invert the sample until the tablet has completely dissolved. Insert the test tube into the slide comparator, then insert the slide. Match the color on the slide to the color of the sample. This pool has a pH of 7.4. Now let's talk about calcium hardness. The calcium level in the pool is important for the preservation of the components used in the filtering and heating of the pool. Think of it this way. Water has a mind of its own. It is constantly trying to chemically balance itself. Since natural water typically has a certain calcium capacity, the water will always want to hold that amount of calcium. Because of this, the pool may be affected. If the calcium is too low, the water will eat away or etch the tiles and heating elements, which contain large amounts of calcium, to raise its own calcium content. If the calcium is too high, the water will leave calcium deposits, or scale, along the pool walls and filtering elements because its calcium content is over capacity. To test the calcium level of the pool, fill up the large test tube to the 400 ppm mark. Add a tablet from the black lettered foil package that reads CH. As the tablet dissolves, the water should turn from pink to purple. When the tablet is completely dissolved, slowly add water, drop by drop, to the test tube. Stop when the water turns from purple back to pink. The corresponding ppm mark is the calcium hardness level in parts per million. This water reads 250 parts per million. The calcium hardness in our pools should be kept between 200 and 300 parts per million. A proper alkalinity, or alkaline level, is important to maintain a steady pH level and also helps prevent etching. To test alkalinity, fill up a test tube to the 400 parts per million mark. Add a tablet from the black lettered foil package that reads ALK. Swirl the water until the tablet is completely dissolved. The water should turn purple. Slowly fill up the test tube until the water turns from purple to green. The corresponding ppm mark is the parts per million of alkalinity in the pool. This water has an alkalinity level of 80 parts per million. A common chemical we use if the pool becomes cloudy is a water clarifier. This clarifier is just a coagulant which, when added to the pool, bonds with suspended particles. This increases the mass of the particles enough so that they sink to the floor, thus making the pool less cloudy. Well, those are the basic chemicals that we test in the pool. If you do a chemical test and find that any chemicals are out of the recommended range, let one of our pool operators know so action can be taken to correct an imbalance. To help you out, I've listed the chemical ranges up here in the sidebar. If you're interested in learning more about pool chemistry, talk to one of our friendly pool operators. See you at the pool!